It's just my business.
Yeah.
Are these?
Yeah, I was like trying to focus on what he was saying. And
The more generalized. You guys got a lot.
yeah, we do. You just figured that out.
Even I was shy.
You can kind of hear class, but then you just.
I'm more often than not responding back to her.
Oh.
She usually just has one-sided conversations while I'm taking notes.
I have to tell her.
Person gossip more than me.
One thing is anyone who does not need the school's gift yet, you know what's happening.
What?
Most of the time, we save it for after or before class because we know.
They always forget that it records and it makes up right.
You're
gonna just use it and just like chicken
Can we start sitting over there?
Oh, and
No, wow.
No, and I was gonna Mr. Dale also would say.
Generalized example of elastic potential.
Oh, rub my belly.
How is
I
elastic
am
potential generated?
Rub my belly.
the spring.
Yeah, that's a spring. The spring was the primary example we were using. If you remember, we said the more generalized versions.
A bolt.
Remember, elastic potential comes from restorative forces.
Yes, I have that reading. Restorative forces.
Gonna be. He was like, yeah, I'll give you the tree.
It's the potential that's stored in an object that has been deformed and is trying to return to its original shape. So again, remember you can use springs, like a bow, would be a good example.
I would say.
But now that we have a new type of potential, you remember we were working with the Work-Energy Theorem, and we had delta change in kinetic energy plus change in potential. But now that expands a little bit, the change in potential has now become the change in gravitational plus the change in elastic, which gives us an addition, which is making our Work-Energy Theorem larger. Now we have the change in kinetic, the change in gravitational potential, and the change in elastic potential. The good thing about solving problems with these is you find out a lot of them will reduce to zero. Okay, so we're looking at, for example, a dart gun that has a spring as its launcher. So initially the spring is compressed to 8 centimeters. But when fired, instead of the spring returning to x equals 0, it gets stuck at x equals 4 centimeters. So the dart still fires. The dart has a mass of 20 grams. What is the muzzle speed of the dart? So where do you, when you say the muzzle speed, where are you going to be measuring it? Where is that?
And she's like, oh, we gotta move, let's go. And then.
We need to have a conversation, but we don't define a word itself.
I'm not even lying. I'm not even saying that.
Right. I know where that's at. So.
I told that to coach too. It's like, this is what it's for. I saw him, and was like. So.
I know.
Yeah. I have
No. The gun.
Like the dog was.
So you have a spring in there. It's gonna fire.
That would have ruined my day. I wish I could get on.
Sometimes I think it's hard. You guys need racist about it?
Dart.
Yeah.
You know, there's just no.
Fish, it's a fish. I didn't say it was a bad. That's a dart.
Yeah. How would you draw a dart?
Those
Better off.
I'll
I'll show you. I'll make it big so you can see.
Fine, it's
Like a dark
dark. I don't care.
Kind of dark. I love your fish art.
Like
Kind of
this,
like an
almost like an
atomic
arrow.
Ah, okay, but that's an arrow.
That's an
And
arrow.
That looks like the darts I play darts with.
What kind of dart?
Well, they're
Is
shooting
it
a gun.
Dart gun? Is it a cow gun?
Yeah, a
What
dart gun.
Kind of dart to draw.
Wait, then
I tend to think of this as like one of those tranquilizing darts.
yeah,
I was
then shouldn't it
thinking
just be a
Those
gun
are
with
fired
flares
with.
and
They look,
everything?
okay,
That's
tranquilizing darts look different.
Yeah, like in the
It's like a
movies,
line
wouldn't
with
it
a
be, like,
feather on
gold
it.
needle with these the red fuzzies at the end of it.
You should have fuzzies.
Yeah.
Yeah,
Like, have you not seen like Madagascar?
Oh, yeah.
Yeah.
Should add color on there.
No, he said.
The dart comes out with a velocity.
I tried. I do it like,
We're not sponsored. I think.
Okay, so we want to find the muzzle speed.
Hey, mom, I'm not.
So the first thing we need to remember is what units does everything have? Remember, energy is in joules. Energy is in joules.
What I said.
Units we need.
Jules.
Jules. Now it works, but originally, some setting.
Energy.
Yours is different, so
Oh,
I wish I had.
it's like, you were super serious. I was like, no kidding.
Or is it newtons and meters?
Okay, so the Newton meter is a joule.
Okay.
How does Newton's break down?
Meters per second.
Yeah, so we need kilograms, meters, and seconds.
Little beat in there.
Okay, also, when we're thinking about our work energy theorem, let's just start with. Gravitational. Potential, elastic potential. Okay. Now, first off, are there any non-conservative forces?
Yeah, even.
Did that happen recently?
No.
This is all produced by a spring. Is there anything non-conservative?
No.
No. So that's gonna be zero. Let's look at the gravitational potential.
You asked if there's anything non-conservative, right?
Right. So what, based off this, how do we take care of gravitational potential?
Zero.
Zero, because your initial and final height are the same.
Oh.
Okay, so what we're looking at,
No, I think he had a gun.
so the change in kinetic energy plus the change in elastic potential.
Area, that shot.
Okay, so we can do 1/2. Final. Having the initial.
I mean, some people did. Most people like mine did look a little fuzzy on some. I think it's. We're talking about. Yeah.
Just eat those things.
Yeah.
Okay. So then. From here, what are we trying to solve for? Which one? Final.
Okay.
What happens to, what's the initial velocity?
Zero.
Yeah. So that part also becomes zero.
This was all of ours.
Okay, so. Oh, let's just go ahead and we'll do. I don't really want to go about it. Yeah, we'll do. Okay, so if, once we rearrange this, we'll end up with something along the lines of 1/2 to e final squared. And that's going to become Okay, now what's the next thing we can do to simplify this?
We got a 1/2.
Yeah, so we're gonna multiply through by 2 to get rid of all the 1/2s. Okay, then we're gonna go. The final square is gonna be K over M. So we're gonna pull K out. And then in here, we're gonna have
Oh, let's see. Oh, it's F squared. It's X.
over there. And we'll firm both sides.
It may be stupid question. But initial one click fine.
Well, because if we go back up here. We start moving things around, so like, you know, the 0 on this side. So if I move that 1/2 KX initial to the left side. And then I move over the 1/2 KX final, it's gonna be X initial minus X final, and then I flip it to get my velocity on the left side.
Oh,
You're just trying to rearrange.
So remember, on your homeworks, I need to see you get to this point. You start plugging in numbers before that. We've all seen South Park. It's, if you French fry when you're supposed to pizza, you're gonna have a bad time.
That's not just South.
That's real life, huh?
Yes,
Liam
I
went.
went skiing for the first time
Uh-huh.
4 years ago. It was not good.
It's not gonna show.
So what do we have? We have 400 meter. 0.02 kilograms. It was what, 20 grams? And in here, we're gonna have 0.08 meters minus 0.04 meters. This is square root. And our final velocity should come out to be about 9.8. Just a second. Nope, not gravity.
Oh, wait, a second square.
Yeah,
Speaking of this.
Is it the gravitational constant?
that's just how the math works out. It's not the gravitational constant. It's the acceleration.
I know.
So it's accelerating this, and
No, I get it, that's why.
then it's going this way. Well, never mind. No, don't, never mind.
It's moving that way in the same way it's accelerating this way.
Yeah, yeah.
What?
You get a flu shot, you're an idiot.
The fact that there's two of them.
Okay,
That one actually gives you
let's read this one. We have a kangaroo carrying a baby in her pouch. If the baby kangaroo has a mass of 1/6 the mass of the mother, how high can the kangaroo jump with the additional load? Normally the kangaroo can jump 2.8 meters without the baby. You think you have enough information to solve this problem?
I don't know.
Well, how much between every
That's what I'm
average?
saying, like, you gotta figure out how much the mother kangaroos really got.
Yeah, there's no way to figure that out.
I was gonna say. Yeah, I'm just like a average mother.
So then know this.
Hey Siri, what's the average mother?
That's not how you solve the problem.
Kangaroos can stand 6 feet, 1.8 meters, tall and weigh 200 pounds, 90 kilograms. Some are much smaller.
You also talk about the average mass of a joey.
Hey Siri. I thought it was gonna be 1/6 of the mother's.
It is.
So 1/6 of 90 kilograms.
Yep, so No.
Well, I guess we're not using the 90 kilograms, are we?
What if you had a fat kangaroo?
But if it's obese, I don't know. Not that, it's body positive. Is it 30? How much they should be jumping? That's the question. That's what I'm saying, like, should they?
I just say it's the mass of the baby kangaroo, 1/6 the mass of the mother. Let's also trying to think of a diagram for this.
Can I just draw it?
If you could draw a full-on kangaroo, you go for it.
Yeah, my own, because it's all.
Kangaroo is rectangle.
That's a beautiful kangaroo.
No.
So this is the kangaroo. White and zero. And the kangaroo's gonna jump.
Kangaroos aren't shaped like.
I don't want him to be like, hey, you're kind of right here, but then I go to my advisor and you're here, and then figure out. Yeah, I don't think, but he probably is on with that. She's thinking. Yeah, I think you.
Kangaroos just asking.
Did you tell that was kangaroo?
So we're gonna start by saying, well.
Bottom box and what's your top box?
Baby kangaroo?
Yeah, which
Yeah,
one?
it's the same kangaroo, just jumps.
Oh, it's just jumping. Jumping
Look.
with the
Yeah, I gotta make my
Baby kangaroo.
baby kangaroo.
baby kangaroos. Jumping.
Oh, I better draw that for you.
I mean, I thought it was pretty accurate. What are you talking about? That's like 10 out of 10 right there.
So let's look at the reducing work, of course, creating kinetic energy. And gravitational energy. Okay? Explain this to me.
I made mine a hexagon right.
So that's your change in kinetic energy?
Yeah, why?
It's the same thing.
Give you all the energy, the gravitation.
Yeah, by the time she reaches what? The top. So her normal jumping height is 2.8 meters. That's at the apex of her jump. So when she's on the ground, her upwards velocity is 0. When she's at the apex of her flight, her y velocity is 0.
They replace each other.
Yeah, so it's gonna have your initial and final velocities at 0. That means the work that we're looking at, we're gonna have. So without the baby kangaroo, we have work 1. And that's gonna be. Yeah, mass of the mother. The Y1. The Y1 is 2.8 meters. Well, 2 can be, well, let's just call it mass 2 right now. We don't know why 2. So here's the thing. Are those two amounts of work the same?
No.
Yeah, they're the same, because without the baby, she jumps 2.8 meters. With the baby, she she has a lower jump. So it's the same work, it's just producing less change in Y.
Higher mass.
Yep, so,
You take.
So work 1 equals work 2?
yes, it does. So your mass 2 is the mass of the mother plus the mass of the baby kangaroo. Okay, so.
Yeah.
So on this side, we're gonna have the mass of the mother, gravity, by 1. And the mother. Mass of the baby, gravity, by 2. Now, over here, this is mass of the mother plus 1/6. Mass of the mother. By 2. How do I add those crazy numbers?
One was
That's a crazy. No.
Yeah, which is what?
7, 6.
7, 6, there you go. Figure one is 6 over 6, and you add 1 over 6. And it can give you.
And then this is track.
Yeah. I heard Lana talk
Oh,
about
no.
Now you can take out
Yeah.
your D and your M.
Yeah. So you see, I don't care how much the mother is.
Maybe you should, though.
Yeah, and this
Maybe
is,
she's
this
not just
is
listening.
culture and society, I think that's dangerous, so.
What's that thing?
There's the door open.
You know, for those, we disappear.
Yeah, what did we see? Like, I saw the other page.
No, you're Y1.
No, there's a tour today.
Shit, I'm.
Y2. How do I solve for Y2?
Why do you use 6, 7 divided by
6, 7.
Yeah, I can do this.
Let me hear what you said.
Seven.
Where's Drew?
I don't, what is that?
6, 7.
I
don't know.
It means nothing.
It's,
Six,
yeah, it's true.
seven.
It really means nothing.
It really
In
means
Philly
nothing.
rap, 1067 is a code for, I think, a dead body. So
That's
it's
not
like
what
a
we're talking
local-
That's not.
Well,
this is.
some say.
That's actually what we should be talking about.
Why do you know that?
I'm
What?
I'm
I thought it was associated.
Okay, so
You're weird.
when you,
1067.
you can divide through by 7/6, which then flips it into a reciprocal.
6, 7.
What's the base?
What is it? What's the reciprocal? I can't read it. What is this?
I'm dyslexic. Can you?
Did you just say it out loud? I'm not listening.
Well, that sounds like you problem.
Oh, okay.
It is. Y1 was 2.8 meters.
Wait, what do you multiply by 2.8?
Stop it. You just
Yeah.
kill him.
I regret to inform you, if you come in here for a battle of wits, you come unarmed.
6, 7.
Is that in the? No. It's just trying to actually do here.
I'm trying to actually make this, you guys, I'm walking into that.
Okay, so
Today.
now this is a more non-traditional way of using the work energy theorem. Part of it was dependent on realizing that changing kinetic energy is going to be 0. Because again, you're looking at the kangaroo on the ground, kangaroo at the apex of flight. Both of those are a velocity of 0.
Makes perfect sense.
When the kangaroo lands, takes her baby out of her pouch, and plants it in the face. Is that what kangaroos do?
Sorry, almost not in the face.
Oh, yeah, they can. Do what?
They actually punch you out in the face.
Yeah, that's actually pretty good.
Wait, what did you say? Even when we said they block. Dang.
I thought kangaroos kicked.
And for those of you who, is it block? So, can someone?
Let it out.
But, and for those of you who study biology, remember that the scientific name for the kangaroo is Tyrannosaurus deer.
That's why.
Tyrannosaurus deer.
Mhm.
That makes sense.
It's just.
Yeah, you didn't miss much.
I remember it saying 6, 7.
Look, your freshman year, you guys got me to use the word slang in a lecture. That. You remember that?
Yep. I should have been born a year early. You should have, so you're good in our chemistry.
Yeah, that was ages ago.
Okay, so
We didn't get it.
That was great.
now we want to talk about the concept of power. Mhm.
You're really clear, like.
Great responsibility.
See?
Let's just say that the power is the delivering of a certain amount of energy over a certain amount of time. Somebody write that. No. Certain amount of energy over a certain amount of time.
E over P.
not P over T,
Generated.
E over E.
that's one.
Maybe.
I also thought of this. Oh, you thought of it?
That works.
Block.
Yeah.
I use my brain. Although.
So the general definition of power is gonna be the change in energy divided by the change in time. And that means that the SI units of power are gonna be
Rules over seconds.
joules over seconds. So 1 joule per second equals 1
I make those
Not.
watt.
Like what's in light bulbs?
Yeah.
Watt.
The unit of power is watt.
And it's
You just write, what's it, it's a W.
Just a W.
Yeah. I mean, for preschool, you can write what, you can write a W.
Half.
What?
You can do joules per second.
Man, better flavors for KG.
Every time I'm into that.
Way after that.
You can do kilograms squared over second cubed.
Candy, you know, like that.
Something right way.
Raspberry.
What did you just say?
I'm like.
Where do you find these pictures at? Just like when they pop up, you're like, this
Oh, no,
is
no, no,
chronically
no,
online, but
no, no,
not
no.
chronically online.
Oh, that'll be a good one.
I thought you made
Generator that I can start. You got the image and I can make operator is different.
Everyone else.
If there's ever a
Is
team
this
of.
one too old for you? Don't you remember the SWAT lady?
That looks like a photoshopped picture of like some act.
I just keep.
No, you can just look up like
you know,
SWAT lady.
Until I pass out. Go off Google for food.
What I should make you do.
Wait, what or what?
What you should make us do is make us each make a meme to put on your thing. Extra credit, we make a meme of each other and we put it on your slides.
Only, programs which most of you don't seem to care about. Yeah.
No, we did that.
Oh, no, they're continuing.
But I don't have to.
That's not,
I think it's extra.
that depends on how much harder I start grading. You're lucky you got Python and I'm not making you do Fortran.
Work on my.
I have neither.
Well, in all fairness, nothing works on a Chrome browser. Except for video games and movies.
That's all you need.
I mean, it plays Netflix like a boss, but
The Chromebook?
okay, so. That is cool. Now. So what's the way we've been calculating energy? So power, since it's energy over time. Yeah. What's the way in this chapter we've been calculating energy? So what's another way we can write power? The work. So power is going to be work delivered over a certain amount of time. And so.
And he said Fortnite in his cards.
Remember that we have work is F delta R cosine theta. The power.
I think he like. put you in a closet. Not used to it.
Now, look at this here.
Anxiety.
How do I get from here? Force times velocity cosine
There
theta.
you go back. Over time. Gotta get rid of it.
It's like not ready.
Boots are nice.
So yeah, you gotta take out your distance of your time. You turn it up velocity. Shut up.
So, one of our primary ways of representing power is going to be the force times the velocity cosine theta between the 2. So the way you can think about that. 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 So the way you can think about that We draw a picture of a cat.
That's not a cat. No, sometimes he does.
In physics it is.
I thought that was your kangaroo.
And then he's like, no, you're confusing us.
I see the safe.
The kangaroo is an upright rectangle.
There's always a plane.
No one ever was.
Never listens to the person who does. I'm not. Even worse.
Let's say we have a velocity, an object moving like that, and we have some force. Some force applied to the moving object.
There's a cat.
Yeah. You put a leash on the cat.
My cat for a while. He did was lay in the
My
grass.
cat.
I saw them doing this thing where put holy water on the cat and the cat spaz.
Oh.
So what we can do is we can move the force and the velocity.
Beatrice's wheel.
And then you see between the two,
Suitcase.
we're gonna end up having an angle theta. So that's the angle that would end up going into the plane and tower.
Yeah.
Who's Beatrice?
Chick who wheel broke on her suitcase, she cut.
Okay, we're gonna do a few minutes of group work.
That was amazing. What if I asked you to be in the group?
But I don't know how to solve it.
Well, yes, you do. I'll help you.
I'm still not used to the map.
So are we gonna just finish this lecture and then leave early?
Depends where we get.
Don loves those shoes.
Little group work.
Right, come here.
No.
So when we were talking about power, this is, I thought of you like up there sitting on your swivel chair like this. SpongeBob. Have you seen this episode?
I picture myself more like the Emperor from Star Wars.
That's good.
Have you ever seen, this is the episode where SpongeBob joined like a marching band? So they took that episode and then they, over the top of it, they placed the song, This Is Why I'm Hot. You should look up, This Is Why I'm Hot songs.
No, trust, okay.
How does it make sense? How does it make sense?
And he's drawn the diagram.
How does it make sense?
Or it's like, I have like, every time this person comes in, I play sexy back by just. It's like.
My sister did. I watched a lot of 90s cartoons.
Aren't you supposed to like pop the popcorn?
As long as I like that 4 degrees is fine.
That's great.
Haven't got that far.
No.
Back, I'll have something written down.
I'm gonna have to go with no on that
I'm
one.
practically signing my name.
Practice doing this problem.
Make better.
Popping my popcorn.
Air resistance, so if it's going down, it's like air resistance should be on.
Well, so let's see.
Tank.
Yes. So the air resistance would go in the same direction as like your friction force.
I know. I wasn't allowed to watch SpongeBob.
It's so actually down.
Let's see here.
Why were you guys allowed to watch SpongeBob?
Ask my mother.
He has more loud
I'll
ones.
call my mother and she can tell you why I was allowed to watch them.
We're gonna have the force of the engine, the force of the air.
It's so funny.
I would not.
And since, now think about this, since velocity is constant, acceleration is zero. So the force of the engine is pulling it down the hill. Air resistance pushing it back up the hill. Velocity is not changing.
My dad will always be up there watching, like, what are you doing, John?
What's the coefficient?
The force of the.
And also don't forget that you have a component of your gravitational force.
Right, okay, so those will add together. You'll sit there, I'll be like watching friends, he'll sit there, he'll watch, and he'll just laugh.
Bind it all together. Then you put a part of it. Fit on it.
No.
As kinetic.
Do I not?
Well, it's not friction, it's just going in the same direction as friction.
Did you like
It's
these?
air resistance.
Like,
You control the vector on there like you were doing,
my name.
friction, and then you put like the force of air.
Water cannon. Steel wool.
Close enough. Now draw your force vectors on there.
No, I would.
Did I draw my car?
Yeah.
So would your air resistance be going this way?
Yes, so the air resistance is gonna be pushing you back up the hill, so the engine's gonna be driving you down the hill.
So this would just be force?
But you could call it force, you could put like a little E on it for engine, force of air.
That's one you last.
What is your brain?
This shows.
So picture myself more as the plankton.
Let's do this.
You just think you're evil. I picture myself as going down this.
You're going down the hill. Let's just go with that.
Guess what TikTok I saw?
I'm going
I saw this person looking over a ledge saying, I wonder what my free body diagram would look like if I jumped off this.
You're gonna have a slight air resistance, you'll hit terminal. If you don't jump from something really, really high, you're not gonna hit terminal velocity.
You've seen this.
What my free body diagram would look like if I jumped off.
Yeah, gravitational vector.
What's this level? It's not mass gravity and I cannot do it. This is just force gravity for my downward.
Yeah, it's, I mean, it's
So I said it's quite-
yeah.
I don't have a question about this, but I just have.
Where did you get that?
So,
I. I told everyone.
November 5th or 6th. HPC.
We're aiming to hear.
5-page paper. I don't know, like,
I don't really have a reason.
yeah, just write like a paper of how inappropriate it is, and this one by Brian Watson.
Did you have everyone else write that 5-page paper? No? Okay, then seriously, writing. Can I tell you my reason?
You not read the syllabus says that this is changed in any class. So,
It'll be fun. Wednesday? No, I didn't read the syllabus. Wednesday I have. Wait, here, Wednesday I have an appointment.
I'll be there the whole time.
yeah, well, so what'll happen is that the exam will be on campus. So you'll just.
Technically, I have to run that. I have to.
And then on the 17th and 19th, I won't be here because I have my UFC on the 18th.
Well, that's not important.
No, that one is important. Do you want me to cry?
Write out any.
I have cried.
You got your internet?
But yes, I will be on these ones and I can bring a doctor's note.
Yeah,
You got an interview?
I just got the.
it's all good.
Okay, perfect.
Is your thing, is your status? But never mind, I think I.
Sure.
Didn't
How'd you
say
find out? They
anything.
email you? Like.
They called.
Sorry.
Mine doesn't even say that. November.
No, it doesn't.
Classes
No,
cry.
it never said anything.
Has cried in
Yeah.
this class? I cried yesterday because I dropped my pizza face first on the ground.
That is all. It's all good. That's what I'm saying already.
They can vouch. It wasn't bad.
We don't.
No.
Natalie gave me a hug and Natalie doesn't like that.
No, but it's like,
If that tells you what.
physics hasn't made everyone in here cry yet, then we need to up the ante.
Sound like my father.
Dr. Everett,
You see
You know how that goes, cause maybe I'll need to talk to Hardy as well.
Yeah.
no.
Yeah, mine just says under review.
Doesn't even say that.
No. Face down was shaped as a pumpkin. Wait.
Station to station.
Made it at home.
See,
We'll take a picture of it. She goes, oh, push it down a little more. Then it fell off my thing, and then I left it on the ground and cried.
application status.
I went to my
apparently
room and screamed
decision
at my
status,
pillow.
none.
So that was just a cherry on top of my day. I cried 4 times yesterday.
Oh, she's got a pirate
Oh
costume.
yeah, mine's decision status says,
Anatomy and physiology,
it just says no.
just trying to think of the
Yeah,
reason.
that's number 1.
The 60 question quiz, I like
The
that.
fact that I had to take a, I had to pay $350 to take a test to get into med school.
Still saying that.
Cried.
She got your pizza on the
You
ground.
got pizza on the ground, cried.
You not looked at the med school application fees?
Because you, wait.
I know, it's just like
it's to-
Just solid for.
Yeah.
Right away.
But my
Yana's looking at some-
grandmother.
Yana's
gave
looking
me
at some-
pizza.
Was it about like $200?
And I cried to be listed as one of those.
Where's speak just.
I cried. I said-
Could just rode with it.
I love the fact that we get. like-
That'd be,
No, no.
yeah.
Yeah, they'd already said that I was.
Yeah, but we're-
It's not saying completed, so I guess I better.
This is
go
over.
email
My,
and
my
say, hey, can I get this?
she told me she was gonna pay for something and I cried all the time. Cause she's like the one who's my hobby.
Yeah, but I think the real crime from yesterday was,
And for.
Well, I genuinely think the pizza was a valid crash out.
It was, like,
I mean, you made it look like a.
It's just a more.
So sad.
Like, dude, you figured this out.
No, I'm still thinking about my pizza.
What do you think?
I told you.
That's.
Some by air resistance, can I put the air protection at my part, or do I have to put it like behind it and go?
Yeah, like this.
Yeah.
Still sending out emails, Carson. You're still sending out.
Okay, so
You're still sending
now I'll
out.
show you how I did the free body diagram.
So weird. After. She was like, there will be. Finals.
Don't watch it special.
Maybe we watch the episodes
The
from his
spare
childhood.
episode, the circle.
That's on those.
It's my favorite thing ever.
Draw mine like that. Iris, did you see that? SpongeBob trying to get his driver's license.
Iris.
Oh, one of them I lost.
Day I died. Like in the beginning of beginning of.
Feel-
It's her outside of this place.
So,
I hate Shelley. She's the strict thing.
we're gonna have the gravitational force.
11.
His life.
That's just lecture.
The force of the engine driving the car.
Honest. This is the problem. The library looked at.
What's this gonna say?
It's force of the engine.
So EN?
Yes.
It's great practice. Grow.
The force of air resistance.
What's the red arrow going down? Force of the engine.
Yeah.
Return. We should.
No, then of course we remember that we're gonna have
The tracks in the ceiling.
What's the red one?
yeah.
EN.
So we have our X and Y components of our gravitational force. And this is pretty much all you need on here.
Okay.
Now, velocity is constant, which means acceleration is 0.
Yay.
How do I start this?
I don't know. It sounds
It sounds like a Friday issue for us to figure out.
GX plus the force of the engine equals the force of the air resistance. Now, you strongly implied it multiple times.
Because you're my office.
Okay, so
Said you read.
I almost lost sleep over it.
I told you I was just joking.
Now, so let's look at our x component. So that's gonna be mg,
Yeah, it's just hate.
mg sine of theta. Force of the engine,
So the lab is probably.
force of the air. So what are we actually trying to solve for here?
I don't know.
Power.
Yeah, so power. So power is gonna be. Okay,
My God, he's the key.
but what force are we solving for? What's gonna go in there? Force of the engine.
Your freaking
Okay. And these are gonna be different thetas, so. Well, that's theta one and theta two. Okay, so the force of the engine. That's gonna be 183 newtons minus 1,000 kilograms. Gravity. Sine of 4 degrees. The force of the engine is gonna be about 299.6 newtons. Okay, we'll finish this up and then, now. The velocity, of course. Is going that way. So when we go to our definition for power, what is the theta between velocity and the force of the engine? The 4 degrees is to solve over here. This is a different theta. It's 0. Because look, the velocity and the force of the engine are going in the exact same direction.
Time to stand, that means crossover.
So that means that the power, force of the engine times velocity. So when you put your numbers in there, you're gonna get about 3595 watts or 3.60 kilowatts. You don't have to. Because some people are uncomfortable with big numbers. Remember in chemistry how we switched from 60,000 joules to 60 kilojoules?
Yeah, I was just wondering that I had to do that.
So on Friday, we're gonna start chapter 7,
Okay.
linear momentum. Boy, that sounded like Harry Potter stuff.
Eva, instead of emailing you, can I just tell you I donated on Monday?
I'll get you.